Hi, David. How are you? Patrick?
Good.
Yeah.
How are you doing? Are you a tennis player, Patrick?
Oh, no.
It was his sister was playing tonight, David.
Oh, it's Molly. Okay.
Yeah. Molly's actually pretty good. She's state ranked and has always been an excellent tennis player since high school.
Oh, is that right? I have another student, Casey Ross, who is
Uh-huh.
really high ranked in high school. I think he's number one. And
From what school?
he goes to Kent, Denver.
Yeah, Kent Denver. Yeah, it's a nice school. Yeah, no, I don't know, but yeah, that Molly's really, really good. I thought you played. I was going to say she'll come over and kick your
I'm
butt.
sure she would. I do play, and she definitely would kick my butt if she's any good. I'm not that good.
All right, David. So anyway, what we're doing obviously is Patrick's got his finals coming up.
Okay.
So we just wanted to review this sheet and see if we can't go from there, identify any areas where we might need some extra work or that we need to prepare a cram sheet.
Okay.
So that's what we
Do
got.
these two sheets, are they to cover tonight and tomorrow, or just tonight?
Yes, this is the entire printout that the teacher gave for the entire exam.
Okay.
So we're looking at the front sheet, number 1 through whatever it is there, 14 or best we can do tonight and clean up tomorrow.
Okay. We'll get at it.
All righty.
All right, Patrick, let's start with simplifying the square root of 60. How would I do that?
Well, you find the square root of 60.
The square root of 60?
Yeah.
What we're looking for is factors that multiply to 60, one of which would be a perfect square, so that we can take it out as a whole number. So what two numbers multiply to 60 where one of them is a perfect square?
I'm not quite sure.
Okay, let's talk about our perfect square numbers. Our perfect square numbers are 1, 4. You want to keep finished for me? In other words, that's 1 squared, that's 2 squared, what's 3 squared?
9.
Keep going.
16. 25.
Okay, for this problem we don't need to go any higher than that. In other words, is one of these numbers divisible into 60 evenly? 4 is. Okay, so 60 would be 4 times 15. Now, it has to be, one of the factors has to be a perfect square because 60 is also square root of 6 times square root of 10, but that doesn't do any good. In other words, because neither 6 nor 10 is a perfect square number. I'm not going to break it up that way. But if I break it up this way, because 4 is a perfect square number, I can replace it with a 2, no radical sign. That's what root 60 becomes. Okay, so if we go to the problem, it's equal to 2 root 15 divided by 2. What's the answer? What's 2 root 15 divided by 2?
Okay, well then you need to focus out and figure out how it goes. It's 2 root 15 divided by 2, so what can you do? Well, that's going to make a 1.
You can have, it would be 1.
Right, in other words, I can divide top and bottom by 2, which gives me just root 15. Or I can think about it this way, just crossing those off. They cancel one another.
Hey, David, just for his to build up on, so on these making the reductions, you just go for the outside number. You don't divide 15 by 2 or whatever number might be under the square root.
15 can't be simplified anymore.
Right.
In other words,
Oh, yeah,
I
that's right.
could change it to root 5 times root 3, but that's not considered simplified because I now have two terms instead of 1. So unless you can pull a whole number out, you can't simplify it any further. Let me give Patrick some practice on these. Let me give him a couple. Simplify that. And always start your simplification process. You're going to break it up into two factors. In other words, the square root of a times b is always the square root of a times the square root of b. So if I can find factors of 20, that's what's going to go here. But not just any factors. Like I said, if I made it 2 and 10, that doesn't help. I can't pull a whole number out of that, any of that. Well, what two factors would work?
Would be 4 and 5.
And then this allows me to convert it to a whole number. In other words, unless you can pull a whole number out, you don't simplify. About this one.
What do you think on that one? 8.
Let's look at our perfect square numbers. This is a good list to memorize, at least up to that point right there.
Up to 5, you would suggest then?
Yeah, most numbers that he's going to get are going to be divisible by one of these. So, what about 80? What can I split 80 up into? Hold on 1 second. Lock my door here. Okay, go ahead.
Are totally multiplying?
So is 80 divisible by any of these numbers?
84 and 1.
4 and what?
1. Wait, yeah. 120.
No, just 20. 4 times 20 is 80. Okay,
Yeah.
so I've reduced it. The problem is I haven't reduced it all the way. What is square root of 20?
It's up 5 and 5.
And 4.
Yeah, 5 and 4.
Okay, now there's another 2 I can pull out. Well, that 2 times that 2 equals 4 root 5. Okay, I gave you this problem to demonstrate something. And that is that you don't have to get to the final answer immediately. Had I realized that 80 was divisible by 16, well, I could have done it a little quicker. I would have made it 16 and 5. 5 times 16 is 80. And the square root of 16 is 4, so I immediately get to 4 root 5. Well, I got there, I just did it in 2 steps. My point is that if you can find a factor of this number that is bigger, you're going to get to the answer faster. But it's not necessary. In other words, it's not necessary that you recognize that 16 is a factor of 80 as long as you realize 4 is. And just, you keep whittling it down. In other words, I now can simplify 20. Okay?
Okay.
About this one. This is probably as big as you're going to have, something like this. What are factors of 200, where one of them is a perfect square?
You could do 20 and 10.
You could. Problem with 20 and 10 is that neither of them is a perfect square. You always want to choose your first set of factors where one of them is a perfect square. Remember, we're trying to whittle this down and pull out numbers. So I could do 4 and 50, right? That allows me to pull out a 2. And then I could work on this and see if I can whittle it down any further. And I would be able to, but if you happen to see that that is 100 times 2, and 100 is a perfect square number, it's 10 squared. So it immediately becomes 10 root 2. Now, let me go back and we'll work. I know that this is 10 root 2, so let's get there a different method. Well, that's equal to 2 root 50, but root 50 is 25 times 2, right?
Yeah.
Okay. Yeah. And the square root of 25 is 5. That's a perfect square number. So now I have 2 times 5 times root 2, which is equal to 10, root 2. Been a long day, sorry. So I get to 10 root 2 either way. It's just how quick you want to get there. And how quick you get there depends on your ability to find the biggest perfect square factor. In this case, the biggest one was 100. But 4 works. In other words, 4 lets me whittle it down. And there's a lot of problems where you're going to use 4 to start with. You may need another one after you start with 4, but most problems you would start 4, which is going to be one of your factors. All right. Solve the equation. You can tell me what the next step is, or just do it and read the next line to me.
You could subtract 16.
Okay, so read the next line.
It'd be 2x to the second equals 12.
8. 24 minus 16 is 8. Now, what's the next step?
Well, then you can you divide.
Okay, by 2. So what's the next line?
X squared equals 4.
Correct. Now, how do I get to x? If x squared equals 4, how do I get x? In other words, we're always aiming for this goal. We're always trying to isolate x. So if x...
Don't you square both sides?
Take the square root of both sides. Squaring is the opposite of the square root. In other words, in order to get x squared to be x, I got to take the square root of that and the square root of that. Okay? So what's x equal to?
2.
This is a mistake that 95% of my students make. It's plus or minus 2. The only thing I can think of to tell people is that whenever you're solving an equation by taking the square root of both sides, always start your answer out with plus or minus.
Okay.
In other words, if x squared is equal to 25, what's x equal to?
Equal to 5.
Plus or minus 5. Notice that minus 5 times minus 5 is equal to 25. So the minus solution is every bit as important as the plus solution. Equally important. Okay? So you will lose points on a test if you omit the plus or minus. Guaranteed that you would lose points. Okay?
Okay.
All right. Let's go on. Okay, so here they're asking us what kind of transformations are being done to this thing. Well, there's 3 of them. First of all, what's the elementary function?
I've never heard that term. Exactly.
The elementary function is, what is the function before they did all their things to it? It's this.
Oh.
That's the elementary function. Okay? Now we got three things we're doing to it. And you've identified the reflection based on the minus sign there. That's correct. What are the consequences of that 4 and that 2? Let's take the one that's inside the parentheses.
Well, the 4, that's a horizontal shift left of 4, right?
Very good.
Because
that's all you need to tell me, yeah. And what's the plus 2?
That's a vertical shift up 2.
Right. Right. Because, yeah, okay. We'll just leave it at that for the moment. Where's the vertex?
Is it at -4 plus 2?
Yes. In other words, the format for the vertex of a standard function is this: a times x minus h squared plus k, where h and k are the vertex. Well, h is -4 and k is plus 2. So that's the vertex.
So which two functions were the vertex, a and k?
H and k.
Yeah, okay.
H and k. A is just a vertical stretch factor, right? And in this case, a is, well, -1. If there was a number after that negative sign, like a 2 or something, then that would be a vertical stretch factor also. But in this function, there's only three things that are happening: reflection, horizontal shift, vertical shift. Does the parabola open up or down?
Would it be up?
Down. Here's how you can tell. The standard parabola that you start learning when you're in algebra is this one: y equal x squared. Okay? It opens up if there's a plus sign in front of this. It opens down if there's a minus sign in front of it. In other words, it's reflected if there's a minus sign.
So
plus up, minus down. And that's true no matter how complicated it is or what else is going on. Okay? So that's easy. The vertex, is it a maximum or a minimum?
It's a minimum.
Correct, because it opens up. An equation for the axis of symmetry. Well, let's put our vertex on there. We know the vertex is at -4, 2. And we know that it opens down. Where's the axis of symmetry? It's that line right there. What is the equation of that line? X equal what?
-4.
Correct. That's the answer to that question. The equation for the axis of symmetry. It's not a point. A lot of people will say the axis of symmetry is at -4, but it isn't. It's a line, and a line has to be defined that way, or y equals, which is a horizontal line. All right, so we're able to graph that. Now, do they have any requirements for you as to how many points they want?
They just want you to graph. I don't think there has to be a set amount of points.
Okay, because 3 points define a parabola, and we only graphed one. We didn't bother to figure out where that goes through. I would have to set this thing equal to 0 and solve it. In other words, make the y value 0 and solve this to figure out what these 2 points are. But they didn't actually ask them. if they wanted us to find those, they would have had a question on here saying, what are the x-intercepts? Then we would have had to define these 2 points, and then we would have 3 points for our parabola. Sketch a graph with the vertex on the grid above. Okay, well, we just did, kind of. It looks very much like this, and that's probably all you need to know. You know what? Let's solve for the x-intercepts anyway, because you're going to have to do that at some point. So the x-intercepts are when y is equal to 0. The y-intercepts are when x equals 0, right? Now let's go back and look at that. I can actually get a third point easier than solving for the x-intercepts. I can solve for the y-intercept, right? And it's easier to do. What is the y-intercept? That's when x equals 0. Well, plug in x equals 0, and what number do you get?
You would have to get 6.
Well, if I plug in 0, now I got 4 squared. What's 4 squared?
4 squared 16.
But there's a negative in front of it, so it's negative 16 plus 2, that's negative 14. So that point right there is negative 14, 0 comma negative 14. And I know that this thing is symmetrical about the line of symmetry. So, and I'm at minus 4 right here. Well, the y-intercept is x equals 0, so if I go over to minus 8, then this point is also on the curve. So I got my 3 points faster than I would be able to solve for the x-intercept. Solving for the y-intercept is always easier because all you have to do is substitute 0 for x, and this, you can figure this out very easily when you substitute 0 for x. If I have to set this equal to 0 and solve, now it's a little bit difficult, but let's make sure you can do that. That's certainly part of this, the nature of this problem. I mean, you want to be able to solve this equation. It's the first step in the next line.
You could subtract 2.
Okay.
So that would be...
Next step, next line.
You could solve the x plus 4 to the second, which would be...
Hold on. Let's get rid of those negative signs. Negative signs, if you can get rid of them, always do. They just make math problems harder. So how can I get rid of them? How about if I divide both sides by minus 1?
Okay.
Turns this positive, turns that positive. Now I don't have any negative signs anymore. Okay? So now what?
Now you solve the x plus 4 to the second.
Actually not. I could do it that way. I could expand it, but that's not the best way to do it. Best way to do it is to take the square root of both sides. Okay? If I take the square root of the left, I get this. What do I get if I take the square root of the right?
X plus 4.
So x is equal to the square root of 2 minus 4. Plus or minus. See, I made the mistake myself. When I took the square root of both sides, I didn't write plus or minus 2. And it is plus or minus. There are 2 values for x. Notice that in my picture, my x-intercepts, there's one there and there's one there. And that's usually going to be the case. Well, where are those? One is Square root of 2 minus 4. The other is minus square root of 2 minus 4. By leaving out the plus or minus, I was going to miss one of the x-intercepts. So that's why it's really important, and you would always lose points if you didn't put it in there, because it's in there. In other words, you wouldn't get both x-intercepts if you didn't make it plus or minus. All right, so that'd be the hard way to figure out the x-intercepts compared to how easy it was to figure out the y-intercept. And both of them give you 3 points on the parabola. So if you only need 3 points, sometimes it's easier to figure out the y-intercept than it is both x-intercepts. All right. So let's start by factoring this. How do I start?
Well, the way we learned it, you have to figure out something that times to get 12 but adds to get 7.
Okay, that's true, but it's not always that simple. If this is a minus sign, it's not that simple, but you're right. But let me go through my process for solving what I call first degree quadratics. First degree because there's a 1 in front of the x squared. That means it's always going to separate the x and x. That's step 1. Separate these two things. Step 2, figure out what both signs are going to be. Both signs, that's a plus and that's a plus, so it's got to be plus plus. Now, because this is a plus, you can do what you said. You're looking for factors of 12 that add to 7. What are they? Let's go through finding factors. I came up with a pretty cool way of finding factors. Always start with that.
Okay.
Now, can I double this and cut that in half? Because if I can, it's got to be the same thing. Okay? Can I do it again? Yeah, I can double that and cut that in half again.
So it would be 4, 3.
Bingo. Those are the numbers we're looking for. By using this method, you can frequently factor difficult numbers to factor. It's not always cutting in half. Let's take 36. Let's find factors of 36. That's not the one I want. I can't think of one. I won't worry about that since I can't think of it. Okay, now multiply these two together.
So you'd have x squared plus 7x.
Okay, we know that. In other words, we know the answer, but how would you do it if it wasn't these two numbers?
Wouldn't you use
FOIL, right? FOIL.
every term by every?
Yeah, every term by every term. I like that much better. You'd multiply that by that, and then you'd multiply that by that, and then you multiply that by that, and then you'd multiply that by that. Every term by every term. So what does that give you? It gives you x squared plus 3x plus 4x plus 12, which indeed is x squared plus 7x plus 12. All right. Now, this is a tougher one. Much tougher. Why? Because there's not a 1 in front of the x squared. If there's a 1 in front of the x squared, they're really easy. These get tougher because we can no longer make statements like factors of 5 that add to 7. That's not going to apply. What's the first step? I got to break this down. How can I do it?
You can have 2x by x.
Yeah, and always make sure when you do that first step that they multiply together again to give you that. Always. Okay. Now, what are both signs?
They're plus.
There's only two factors of 5, 5 and 1. So either it's got to be 5 and 1 or 1 and 5. Which is it?
Would be 1 and 5.
Well, let's check. Now, I don't need to check that number. I did when I broke it apart. I don't need to check this number. I did because I was looking for factors of 5. The number I need to check is the middle term correct? Well, the middle term comes from the inside and the outside. That's plus 1x, that's plus 10x, that adds to 11x. That's not,
Oh yeah, so it
must be
5
and 1. Let's check that. 5 times x is 5x, 1 times 2x is 2x, those add together to 7x. Multiply this back together again, term by term.
You'd have 2x squared plus 7x.
Well, plus 2x. We're doing every term by every term.
Plus 2x plus 5x. And then, of course, times 5. Plus
now we can add those two together to get the 7x that we started with. All right. There's some term that I'm going to be able to write in there that is going to allow us to write this as x plus some number quantity squared. The way you come up with it is by completing the square. How do you complete the square?
I was once again terrible at these last semester.
Okay, that's fine. I know. I need to ask, so whether I'll know I need to explain it or not. The way you complete the square is you take half of the coefficient of the x and you square it. Well, half of 8 is 4 squared. Actually, that's all I need. If I wanted to make this a perfect trinomial, I'd have to put 16 in there. Half of 8 squared. Now I can write that expression as x plus 4 squared, a perfect square trinomial. What are they calling? Oh, perfect square trinomial. Yeah, because this is the trinomial. And it's a perfect square because it breaks up into a single linear factor squared. So let me give you another one. How would I complete the square here?
Take half of 16 and then square it.
Okay, so what would I need to add?
8 times 8, so that would be 64.
Right, and whenever I have completed the square, I know I can always write this as whatever half of 16 was. By virtue of the fact that I completed the square, I'm guaranteed to be able to write it as a perfect square. Okay? Now, the next question asks you to solve the problem by completing the square. Well, this actually factors nicely, and that would be the easiest way to solve it. Notice that it factors into x minus 10 and x minus 2. It gives you all three terms. So I could solve it by factoring easier than I'm going to be able to solve it by completing the square, but you need to know this technique. When you complete the square, get rid of the number on the others, put it on the other side, like that. Exactly the opposite of what they teach you to solve a quadratic. Usually it's put everything on one side and set the other side to 0. But if you're completing the square, not so. Okay? Let's complete the square on the left side. In other words, the left side no longer has any numbers. It just has an x squared and a 12x. So, and I'm always adding when I'm completing the square because I'm taking half of this number and squaring it. So it's always going to be plus. What do I have to add?
So you take half of negative 12?
Just half of the 12.
Alright, so that'd be 36.
Okay. So right now I'm looking at the same thing this is. If I write 36 in there, I've changed it unless I add 36 to the other side. Now I can do that. Okay. Now how can I write this on the left? Remember, I can write it as a linear factor squared. It's going to be x minus what? Quantity squared.
Would it be x minus 24?
No, it would be x minus 6. Whatever you got, when you took half of that number, that's what goes there.
Alright.
Okay? And on the other side, I got minus 20 plus 36, so that becomes 16. Now, let's keep going. What's the next step in solving this?
You square both sides.
Square root both sides. What's the next line?
Wouldn't it be x minus 6
Equals what?
equals 4?
Plus or minus 4.
Plus or minus.
That's going to matter because now x is going to be plus or minus 4 plus 6. So what are the two values for x?
Positive 10 and minus 10.
Well, positive 10 when I use the plus, but when I use the minus 4, what is it? What's minus 4 plus 6?
2.
Those are my two solutions, 10 and 2. And notice that I did it by completing the square, whereas I actually could have factored it into x minus 10, x minus 2 immediately and got my solution right away. But there's a lot of reasons why you have to know how to complete the square. This isn't a problem where you would have to know how to do it, but it might as well do it with that one. You know the quadratic formula?
A little bit, yeah.
Well, what is it exactly?
Isn't it x equals minus b?
Here, I'll give it to you. And then I'll show you how to memorize it.
I have written down it.
We'll get it down again.
The part that is inside the radical has its own name. That's the discriminant. B squared minus 4ac. Not the square root of that. This is the discriminant. It's got its own name because a lot of times the very first step in solving an equation is to analyze the discriminant. That tells you whether it's going to have real solutions or complex solutions. If this discriminant is a negative number, well, when you take the square root of negative numbers, you get I. So you get complex numbers. If this discriminant is positive, you're going to take the square root of a positive number. You're going to have real solutions. And if this discriminant is exactly equal to 0, then this is going to be your answer. One solution only. The part that I just circled, minus b over 2a, what else is that? That's the equation for the line of symmetry of a quadratic. In other words, when they ask for the vertex, if they'd asked for the vertex of that, well, I can immediately do minus b over 2a to get my x coordinate of my vertex. So they teach you minus b over 2a. At least they should have. Did you get a minus b over 2a?
Yeah.
It's 19 hours.
What's that?
It's just the computer, David, keeping time.
Okay. Oh, that's what that noise was. Okay.
Yeah, 7 o'clock.
I thought I was having an audio problem for a moment.
Yeah.
Uh,
Sounds like the interviews are coming down.
So one way to memorize the quadratic formula is to break it into two parts. You got this part, which is the equation for the x-coordinate of the vertex, plus or minus the square root of the discriminant. So if you tend to think of it in pieces, it's easier to remember. Okay, well, here, with this equation, what is A, B, and C? This one.
A would be 3.
Minus 3.
Then B would be 2, and then C would be 5.
Okay. Don't omit the signs. I mean, you don't need to write these pluses, but if that would have been a minus, then C is minus 5. Okay? So what's the discriminant? What is B squared minus 4AC?
Let me figure it out.
You see the way I've written it there?
Yeah.
When you are figuring out the discriminant, always write it like this, where you write A, B, and C out. Don't skip anything. Don't try to do that math first before writing it. The key thing here is to get the sign right. Okay? Now, once you get it to this step, the next best thing is to multiply those three numbers together. When you multiply those three numbers together, what do you get?
Negative 60.
Okay. Now, what is 4 minus a minus 60?
That's negative 64. I mean,
Two minuses make a plus when you're adding and subtracting. So remember when I said change all subtraction problems to addition problems? Well, there's the subtraction sign. So that's what I'm going to turn into a plus. And if I change that, I got to change the sign on what was being subtracted. So that's why two minuses turn into a plus. So the discriminant is 64. Not the square root of 64, but 64. Okay?
okay.
That tells us that there are two real solutions to this quadratic. Had this been a negative number, I would have known that there were two complex solutions. Had it been 0, I would have known that there was exactly one real solution. Well, question B, how many and what kind of solutions does the discriminant tell you?
There's 2.
There's 2 real. Not just 2, but there's 2 real. Because if that number's negative, there's also 2, but they're both complex. Solve using the quadratic formula. Okay, well, we already know what that is, right? That's 64, so we don't need to go through that again. What's B? What's this going to be?
B would be
Minus 2.
Yeah.
And what's the denominator going to be?
It'd be negative 3, so that'd be 6.
Minus 6. It's 2 times negative 3. So it's minus 6. Okay, now let's simplify this. That is minus 2 plus or minus 8 all over minus 6. Well, when I do the plus, what do I get?
You get 6.
I get 6 in the numerator, but I got minus 6 in the denominator. What does that simplify to?
Wouldn't that be negative 1?
Huh? And when I do the minus, what do I get?
Too much.
What's minus 2 minus 8?
Negative 10.
Over negative 6. And what does that simplify to?
Uh, 5.
Positive 5 over 3.
Positive
In
5.
other words, the negatives turn positive. If I divide top and bottom by negative 1, I get this. And then 10/6 equals 5/3. Always check to see if you can just cut each in half. In other words, if I'm trying to simplify 10/6, they're both even numbers, so I know they're both divisible by 2, so I can always whack it down that way. Won't always get there. It's kind of like simplifying radicals. You don't always get there the quickest, but you always get there. Okay? So it's important to know that the solution to that is one solution it uses the plus, the other uses the minus.
All right.
All right. So we got our two solutions, minus 1 and 5/3. What are the x-intercepts of this function?
Well, there's negative 1 and negative 4.
Let's see, 1, 2, 3, 4, 5. Negative 1 and negative 5. What's the y-intercept?
Looks about 6.
I think it's 5. 1, 2, 3, 4, 5.
No, yeah, you're right.
Positive 5. Okay. B, write the following in vertex form, x-intercept form, and standard form. Let's do x-intercept form first. And there's a reason for it. What two linear factors are going to be multiplied together?
The x and y.
Well, it would be x plus 1 times x plus 5. Notice that x-intercepts are when y is 0. Well, if that thing is equal to y, well, when one of the intercepts, I plug it in, this is 0. And when I plug this one in, this is 0. So it satisfies that. And that's x-intercept form. Okay? Let's put it in standard form, the next easiest. Standard form being where everything's on the left, zero's on the right. Multiply those two, term by term.
Right, so that'd be x squared plus 6x plus 5.
Okay, that's standard form. Now the last form is vertex form. Okay, vertex form is y equals a times x minus h, which is the x-coordinate of the vertex, plus k, which is the y-coordinate of the vertex. Well, we can read the vertex. The vertex is at 1, 2, negative 3, 1, 2, 3, 4. So the vertex is negative 3, 4. So plug in everything into that and see what you get. Y equals what? We'll leave that as
Like-
A for the moment.
Ax minus 3.
X minus a minus 3. The biggest mistake people make in algebra is dropping negative signs when they shouldn't. In other words, x minus a minus 3 gives you x plus 3 plus 4. K is plus, K is plus. Now, can I tell what A is? I can only because we did the standard form first. A is going to be the coefficient of this thing. So I know A is 1. So I can get rid of it. Okay? Notice that if I take this, I'm now in vertex format. And if I were to multiply it out, would I have this x squared plus 6x plus 5? Well, let's see. X squared plus 6x plus 9 plus 4, that's 13. Ah, the vertex was minus 4. This point right here is minus 3 minus 4, which makes this, I got the vertex form wrong. That's a negative 4. Now it's plus 9 minus 4, which is x squared plus 6x plus 5, same as standard format, which it has to be. Because all that did was verify that A was 1. Okay? So,
Okay.
there's the three formats. There's the Xintercept format, which is merely the linear factor times another linear factor, and you get the linear factors from knowing the Xintercepts. It's always the other sign of that. Okay? Standard format we got by multiplying those two together to get this. And vertex format we got by seeing the vertex was at minus 3 minus 4, and that's what h and k are, is the x and y coordinate of the vertex. All right. Part C. I'm not sure why they have part C here, but let's fill it in with some values. Let me leave the standard format up.
Oh, can I ask you a question? Can I have the formula for the Xintercept in the standard format?
I'm sorry, what?
Can I have the formulas for standard format and Xintercept? So I can
Yeah. For the Xintercept format, if you know the two intercepts, then it's x minus one intercept times x minus the other intercept.
Okay, let me just.
Our two intercepts we can see are minus 1 and minus 5. Therefore, it's x minus a minus 1, which is x plus 1, times x minus a minus 5, which is x plus 5, and that's how we got that first form, Xintercept form. And, excuse me, it's not equal to 0, it's equal to y.
So did you get the formula?
Yeah.
Okay. You sure?
All three of these are equal to y. The standard format is y equals on one side, and on the other side is all your x terms and your numbers.
Yeah, I got it.
Okay. Now let's create this table, x and f of x. And as all you have to do to create this table is put some whole numbers in for x and figure out what f of x or y is. F of x is the same as y. So using the standard format, x squared plus 6x plus 5, pick a value for x and let's figure out what f of x is.
1.
What's f of x? You plug in 1 for x, what do you get for y?
Just hold on. You get 13.
I think you get 12. 1 squared is 1, plus 6 is 7, plus 5 is 12. Pick an easier value for x. Never forget 0 makes the calculations really easy. Because I know that got to go to 0, that's got to go to 0. So the only thing left is that. Okay?
Okay.
How about 2?
That'd be 4 plus
4 plus 12 is 16, plus 5 is 21. Normally, we put in some negative numbers. Well, do I know what the answer is when x is minus 1? Remember, that's the same equation.
That'd be negative 12.
No. If you plug in x of minus 1, you immediately get 0 right there. 0 times anything is 0. Remember, that's x equal minus 1. We can see that y is 0. If I plugged in minus 5, I would also get y of 0. Okay, so I could go down here and finish this table if I wanted by plugging in a minus 5. I know that's 0. And maybe you'd want to do a couple other numbers. They don't say how many numbers they want you to put in this table, do they? No.
No.
Okay. All right. The only thing that was not totally clear there was coming up with a, because a isn't always 1. But I suspect in any kind of problems like this that you encounter on your test, you can almost assume a is going to be 1. If these intercepts, if there's a 1 there and a 1 there, then a is going to be 1, always. If these two intercepts were at different places, and maybe we had a 2 in front of here, and the two factors were 2x plus 1 times x plus 5, well, now a isn't going to be 1, a is going to be 2. A is always what you're going to get, the coefficient of that right there. That's what a is going to be. In this case, we had the x-intercept format, and we can multiply those two together to get standard format. Now we can see what the coefficient of that is, and I know a is 1. And now doing the vertex format merely requires us knowing where the vertex is, and we can read that off the graph. It's right there. That's h and k. All right. Let's see, is that, no, we got a whole nother side to this page. Or is this the second page?
No, that's the right-hand side of page 1.
Okay, cool. If I draw this picture, when you kick a rugby ball up in the air, it has a parabolic motion. All motion is parabolic. In other words, if I throw a baseball, if I kick a football, anything that's affected by gravity ends up being parabolic. In other words, this is where the rugby ball is to start with. It gets kicked. Okay? And the equation of this parabola is the one right here. Y equals minus 16t squared plus 32t, where y gives you the height. That's the y-axis. That's the x-axis. So if I want the height, okay, let's see. Question A. Graph the function and label the key features, the x-intercepts, y-intercept, vertex, all of that. Well, I got one x-intercept, right?
Yep.
We'll start off.
If, remember the x-intercepts is where y is equal to what?
0.
Okay, so if I plug in 0 and try to solve where this occurs, that's step 1. How do I, only this is not the x-axis, this is the t-axis. Excuse me for not clarifying that right away. In other words, with time, this rugby ball goes up in the air, hits its peak, comes back down, lands on the ground. And the horizontal axis is measured in seconds, time. So if we want to solve for, our first thing to solve for the x-intercepts is finding these 2 points. Well, we can do that by solving this equation. How can I solve this equation for t? Here's what you want to think of. If something is equal to 0, and I can turn a sum into a product, I can solve it. I can't solve it when it's like this. But if I can turn this into one thing times another thing, then either of those things can be 0. You don't get 0 from a product unless one of them is 0. Well, how can I turn this into a product? Sounds like factoring to me. Can you take a greatest common factor out of that?
Yes.
What is it?
It'll be 4.
I could actually take 16t out. In fact, I can take minus 16t out as a greatest common factor, leaving behind t, because this times that equals that. In other words, whenever you're factoring something, always do that. When you come up with the first thing, make sure that this thing times this is equal to that. And it is. And the next thing is going to have to be a minus 2 is minus 2 times minus 16t equal to plus 32t? Yes. I just turned the sum of two things into a product. I have the product of minus 16t times t minus 2. So if I want to know where this thing is equal to 0, either this thing's 0, which means t is what?
Be 0.
Okay, that's one intercept. Or this thing is 0, meaning t is what?
Negative 2.
No. Positive 2. You see why?
Yeah.
In other words, t minus 2 has to be equal to 0, therefore t is equal to 2.
Oh, I see.
Okay, so this intercept is at 2 seconds. So I got my x-intercepts, part 1, done. What's the y-intercept if you just look at the picture?
It's that's 0.
Uh-huh. In other words, it crosses the y-axis at 0. That's where we started. You don't always. Sometimes with projectile motion, if you're hitting a baseball, you're hitting it 3 feet off the ground, in which case this thing would start at 3 feet and go up. And there'd be another term in this equation. But, okay, so we got our y-intercept. Our vertex. What was the vertex again? The formula for the vertex?
That was
First part of the quadratic?
that was y equals a
Minus b over 2a.
Oh.
Remember that first part of the quadratic?
Oh,
It's this plus or minus the square root of the discriminant. Well, this gives you the x-coordinate of the vertex. So what's b?
B is negative 16p.
No, a is the coefficient in front of the squared term. B is the coefficient in front of the non-squared term.
It would be 32.
Well, 32 is b, minus b is minus 32. A is minus 16, so 2 times a is also minus 32. So the x-coordinate of the vertex is at 1, positive 1. But they want the whole vertex. They don't want just the x-coordinate. This minus b over 2a merely gives you the x-coordinate of the vertex. Well, how would I get the y-coordinate? Here's our equation. We know the x-coordinate is 1. What's the y-coordinate going to be?
Actually, it's the t-coordinate, right? Follow
Excuse me. I apologize. Yes, I keep confusing it. Yeah. In other words, the horizontal axis doesn't always have to be x. We tend to think of it as always being x, but in a problem like projectile motion, it's usually time. It's not x, it's t. So plug in 1 for t. In other words, the t-coordinate of the vertex is at 1. This is a plus 1 right there on the x-axis, or the t-axis. So what's the y-coordinate when t is equal to 1?
Don't you just plug in?
You do.
1?
You do. What do you get?
Would it be minus 224?
No, we're not squaring the 16.
Oh.
We're only squaring the 1.
It would be 16.
Yeah. That means that point right there is 1 comma 16. Means it occurs right there. So we now know how high the rugby ball is going to go. It's going to go up to 16 feet at its peak. If you kick this rugby ball and you were in a building that had a ceiling of 15 feet on it, you'd hit the ceiling. If you had a ceiling with 17 feet on it, you'd be fine. So we've got the x-intercepts, the y-intercept, there's only one of those, and the vertex. Include title, labels, and scales on this graph. Well,
There's a label. I understand.
you know how to do that at this point? Titles, labels, and scales. This is the y-axis. This would be the t-axis. You would start here, draw it up to there, put a grid on there that allows make sure your vertex occurs at 16 and that it comes back down at 2. And furthermore, we know more information about this. We know that the ball is going to land 2 seconds after it's kicked. It's going to hit its height 1 second after it's kicked, and that height is going to be 16 feet. That's pretty much everything there is to know about that ball.
This would not be
Okay.
16 unless you...
I see there's two other questions here I didn't notice first, but I think we've probably answered them. What does the vertex represent in context of this problem?
The ball's height, max
The
height.
place where it hits its maximum height, yeah. How long was the ball in the air for?
2 seconds.
Correct. The distance between its starting time and its landing time. It took off at 0 seconds, it landed at 2 seconds, it's in the air for 2 seconds.
Right?
Okay. These are fairly straightforward. How am I going to do this?
Wouldn't you just square everything?
Well, yeah, let's go over 3 formulas. If I have b to the x times a same number to the y, what do I do with those? Can I combine that?
No.
Actually, you can. In other words, if I had 2 to the third times 2 to the fourth,
Oh, I see.
what does that equal to?
Wouldn't that be
What do I do
to the
with
sum?
what do I do with the exponents? I add them. So this is going to be b to the x plus y. Okay? In other words, if I have the same base, I can add exponents. If I have the same base and I'm dividing,
you
subtract exponents. And the third case is if you have the same base that's being exponentiated, that's double exponentiated, like that, which is the case here. We got exponentiation going on inside the parentheses, and we have the whole thing being exponentiated again. What's this equal to? Multiply the exponents. Notice the pattern. When I am multiplying the bases, I add the exponents. When I am dividing, which is one level less than multiplication, right? If you think of math like that, the multiplication is one level higher than addition. When we are dividing, we subtract the exponents. Subtraction is one level less than division. And when we are double exponentiating, we multiply. Multiplication is one level less than exponentiation. So that's one way to remember these 3 formulas. Okay, and these are critical for all problems like this. All 3 of these formulas are going to come in to solve these 3 problems. So, the first one, we're going to use this. I've got exponentiation going on in here and exponentiation going on out there. So let's take it term by term. In other words, that minus 4 is also being squared. So what's the first answer? What's minus 4 squared?
Isn't that 16?
Positive 16. Now let's take the x squared that's being squared. What's that going to be?
4.
Multiplying. And now take the y cubed that's being squared. What's that going to be?
It's going to be y to the 6.
Yeah, that's all there is to do that problem. Is just apply this formula to every number or variable you encounter. This is just a series. I could actually eliminate this dot here and make it 4xy to the third times 6x to the sixth y squared divided by 12xy cubed times x to the 10th. First thing you want to realize is that's the same thing as that. Okay? Let's take all numbers first. Multiply the top, divide by the bottom.
Okay, so that would be
4 times 6 divided by 12.
that'd be 2.
Okay, 2 in the numerator, right? Now let's take the x. And probably the best way to do this is to do the top. If I do just the x times the x sixth, what do I get? What's x to the 1 times x to the 6?
X to the 7.
Okay. Now do the bottom. What's x to the 1th times x to the 10th?
X to the 11th.
And now put them together. What do you get?
X to the 18th.
No, we're dividing.
Oh,
So we got to subtract. 7 minus 11.
so it'd be X to the negative 4.
Okay, we'll start there. We're not going to leave that as our final answer, but that takes care of all the x's. So far, we've taken care of all the numbers and all the x's. The only thing left is the y's. What's the numerator of the y's? What's y to the 3rd times y to the 2nd?
Y to the 6th.
5th. We're multiplying, therefore we add.
Oh, yeah.
We always
sorry
do
about
one level less with the exponents. The only y in the bottom is y to the 3rd. Now simplify that. Is that equal to?
It's Y to the 2nd.
Okay, so there's my answer. But usually they tell you don't leave any negative exponents in your answer. So how can I write this without any negative exponents? In other words, what can I do with that right there? You have a negative exponent, move it to the other side of the fraction bar and make it positive. It's as simple as that. So if I move this to, there's the fraction bar. If I move that to the other side, I'm going to have 2y squared over x to the 4th. And there's your final simplified answer. What is this equal to?
Equal to X to the 5th.
Well, it's equal to 1 over x to the positive 5. In other words, all I do is move it to the other side of the fraction bar and change its sign. So, what is this equal to?
Would it be X to the 2?
That's how you handle negative exponents. They have nothing to do with negative numbers. It merely tells you which side of the fraction bar it belongs on. Okay, let's take C. Let's see. You always kind of work, you want to do these from the outside in. This 3, that's only operating on that. Okay? So let's take care of that 3 before we do anything else. In other words, let's not change this yet. That's the left part. But what does the right part become when we apply this 3 to every term inside the parentheses? What happens to the 5? What's 5 cubed? It's 125. Now, what happens to the x?
Becomes x to the 6th.
No, we're multiplying exponents, right? In other words, we're doing double exponentiation here. That's an x to the 1 cubed. So if I multiply those, I still got x to the 3.
Oh, I see.
And now what happens to the z?
It becomes x to the z to the 6th.
Well, multiply.
Against. Oh, I see. It's a 3, not a 2, so it becomes z to the 7th.
Multiply. You're adding.
Oh, multiply.
Yeah.
Become 12.
Uh-huh. You see why? In other words, this is exponentiation, which means we're going to multiply the exponents. I'm going to multiply that times the 1 of x, multiply that times the 4 of z. So, we've gotten rid of this cube now. Now we're ready to do this and this. Multiply each separately. What's 4 times 125? If you had $1.25, and you were 4 of you that each had $1.25, how much money would y'all have?
Would it be it'd be $5, so that'd be 500.
What's the x exponent going to be?
Would it be
Multiplying the bases. So what do I do to the exponents?
addition? So it'd be x to the 6th.
And the y, there's only one y, it's over here.
Y to the 2nd.
How about the z?
Z to the
You
13th.
got it. It really is all about those 3 rules, which I've erased now. If you remember those 3 rules, these problems are a piece of cake that you can't even hardly miss them. In other words, they become very simple arithmetic problems.
Hey, David, can you, just to make sure that he has them, can you state the 3 rules again?
Yeah, let me do better than that. Let me make up some problems and make sure he can do them.
Be 3 to the 9th.
Okay. About 3 to the 5th divided by 3 to the 3rd.
3 to the 2nd.
And finally, if I had 3 to the 5th, and then I raise the whole thing to the 4th power, what's that going to be?
3 to the 20th.
Okay, those are the 3 rules. Now, if I had 3 to the 4th times 2 to the 6th, can I do anything?
No.
No, it's got to be same base or same exponent. There's one other rule. The other rule is if I have a to the x times b to the x, notice that this is different. The first 3 rules were same base in all cases. But if I have a different base and same exponent, I can combine that. That's ab to the x. But if I have different base and different exponents like this, I can't do anything with it. In other words, if I have x cubed times y to the 4th, that's my final answer. I don't make that xy to the 7th or anything else. There's really only 4 situations. And that's where you have the same base, multiplication, division, or exponentiation. And the other is where you have different bases, same exponent. And that works with division also. In other words, if I had a to the x divided by b to the x, I can turn that into the entire fraction a over b to the x, like that. All right. Fractional exponents. that 3 halves basically mean? What does it want us to do?
So, 16 to the third power, but you want to find the second square root of that.
Right. But always do the denominator first. It'll make these a lot easier. In other words, if I have to cube 16, I get a giant number. Taking the square root of that giant number, I'm not going to be able to do that without using a calculator. But if I take the square root first, I get a nice small number, which I can then cube. So always do the denominator first. What's the square root of 16?
4.
So this is the same thing as 4 cubed. And 4 cubed is 4 times 4 times 4, 64. And you would get that number if you did have a calculator and cubed 16 and then took the square root of it, you'd get 64. But we didn't need a calculator to do it this way. The bottom one. And you can be sure that the root is always going to be a whole number. They're not going to give you the problem if it's not. In other words, the cube root, that's what this 3 means, is the cube root of 27, which we're then going to square. Well, what small whole number is the cube root of 27? When I say small whole number, that means it's going to be 2, 3, or 4. And it's always almost going to be that. Maybe 5, occasionally. What's the cube root of 27?
I'm not sure.
Well, take one of those numbers I just suggested and multiply it by itself 3 times. What's 2 cubed?
Up, so it'd be 3.
Right. So the cube root of 27 is 3. Then we're going to square 3. These problems become very easy as long as you do the bottom first. In other words, the other alternative would be to square 27, which again is some number over 700, and then figuring out how to take the cube root of it. Who knows how to do that? I wouldn't know how to do it without a calculator. But you're not going to get these problems unless you can do the bottom first and easily, and it'll be a whole number, I guarantee it. In other words, when you try to figure out what the cube root of 27 is, don't consider any numbers other than 2, 3, 4, 5, those kind of numbers. It's always going to be one of those numbers. Let me make one up for you here. What's the cube root of 64? Knowing that it's got to be either 2, 3, 4, or 5?
4.
Okay. What's 4 squared?
It's up 16.
These are all easy also. Only because they give them to you easy. In other words, if I gave you this, I can't do that without a calculator, nor can your teacher, because we don't know what the cube root of 28 is. So they're only going to give you these problems if that root is a nice small whole number.
Remember that, okay, because that's important.
Yeah, you don't have to figure out what the cube root of 27 is if you know it's a small whole number, just test 2, 3, and 4. And you did, and you figured out that it had to be 3. All right. David, are we going to 8 o'clock tonight or 8:15?
We're going to go just to 8 o'clock tonight.
That's fine, and I will only charge you 1 3/4 hours tonight.
Well, whatever. You know what? You can charge me for the 2 hours.
I don't need to do that. I'll charge you exactly what we do.
Right.
I just didn't know whether you wanted to stop at 8 or go to 8:15. Okay.
Yeah, we got something else we got to move to. So yeah, do whatever you do is fine. And then tomorrow, obviously, we straightened out. I got you at noon for a couple of
Right,
hours. So we'll
right.
wrap it up.
We'll have time, I'm pretty sure, to finish most of these. Does that say 8/3?
Yeah.
What's the first step here?
You could do it in the parentheses.
We're doing double exponentiation, right? So what are we going to do with those two exponents?
Yeah, times them.
Okay. So this becomes 5 to the, what's the product of these two fractions?
The 8 over 1.
8 over 12.
8 over 12.
Multiply numerators, multiply denominators. 8 over 12 is the same as 2 over 3. Okay. Now, write your final answer in radical notation, not exponential notation. So how would I write this using a radical sign? First of all, it's the cube root.
So you put cube root 5 in the second.
There you go. That's our answer right there. Rewrite the expression using rational notation. I think he meant radical notation.
So you'd be...
No? I guess he wants us to express it with exponents.
Yeah, so would it be 3 to the 4/5 or 5/4?
Which one?
5/4.
Okay. Remember, the root is always the denominator. And can we do anything with that? No. The way I tell whether we can do anything with this or not is if I can't take the fourth root of it, we can't do anything with it. Okay? I mean, that's not always going to be the case, but on these questions, that's always going to be the case. I can't simplify this if I can't take the fourth root of this number. In other words, if I had this, can I simplify that?
Yeah.
What's the fourth root of 16?
The fourth root of 16 is 2.
Okay. What's 2 to the 5th? 32.
Up 32.
Yeah.
You got to multiply.
Oh, yeah.
Yeah, he's getting tired, but you got to multiply. I'll explain. You got to take your time. You got to do it a little bit if you can't get it up.
Yeah.
Focus too deep.
We got just a few more minutes here to get through this page. I think we'll be able to get through this problem and then we can stop.
Good luck.
All right. Graph the function showing at least 3 points. State the transformations in the domain and range. All right. What's the elementary function? In order to figure out what transformations are taking place, we need the elementary function. What is it?
X squared.
It's the square root of x. In other words, it's everything you see here without all the adjustments. We know that's a reflection. We know that's what?
That's the vertical stretch of 2.
Good. Plus 1 means what?
That one's a horizontal shift left of 1.
You got these down good. And what's the minus 3?
It's a vertical shift down.
Okay. So if I remove all of those transformations, I'm left with square root of x, right? That's the elementary function. So what they're asking for is how do we have to transform that to get this? Well, I had to reflect it. Always do your reflections first. And then I had to vertically stretch it by 2. I had to shift left by 1. And I had to move it vertically down by 3. So that's the transformations. Let's examine the domain and range of this function, not the elementary function. of f of x. How do I figure out the domain?
Well, you could
Refer to which variable?
yeah.
Okay. And it means what?
Where the x starts and where
Well,
it goes.
it actually means all values of x that you can put in there. Can I put -3 in there?
No.
No, because I can only take the square root of positive numbers or 0. So the way you solve the domain here is you let everything inside the radical sign be greater than or equal to 0, because that's the only way we can take the square root of it, is if it's greater than or equal to 0. I now solve this inequality. What do you get? If x plus 1 is greater than or equal to 0, what's x greater than or equal to?
1.
-1. Remember, you got to do the opposite. 1 is being added right now, so we got to subtract it. So that's the domain right there. X can be anything you want as long as it's greater than or equal to -1. Now let's talk about the range. Range is always much harder to figure out. Range is the allowable values that can be. What do we know about that range-wise? Positive or negative?
It's going to be a positive.
Always, right? Or what's the smallest it could be?
0.
Okay. So if this thing, the smallest this thing can possibly be is 0, then what's y going to be? 0 minus 3, right? So
Yeah.
y can go all the way down to -3. Is there any way y can be less than -3?
No.
No, because for it to be less than -3, this would have to turn out to be, hold on. I've screwed up here. Just a second. This can only go down to 0, but it can be positive, right? In other words, the square root of 99 plus 1 would be a positive 10 being multiplied by a negative. So I could have -20 minus 3. So this can go lower than -3 because this can be a negative number. We know that what I have inside the square is always positive. So we know that if I take that always positive number and multiply it by -2, it's always negative. Well, I can have as big a negative number here as I want because I can have as big a positive number as I want. So this is going to be the square root function reflected. Remember, the square root function looks something like that, the elementary function. But the first thing I'm going to do is reflect it. Well, that makes it look like that instead. And then I'm going to vertically stretch it, which makes it look like that. And then I'm going to move it 1 unit to the left, which puts it over here. And then I'm going to move it down 3 units. So I'm going to start it there. And it's going to go like this. Okay, so that's a graph of our function. Now tell me what the range is. In other words, I can see from this is x and this is y. I can certainly see the domain, x has to be greater than or equal to -1, right?
So the range would be -3 to negative infinity?
Yes, only go the other way. In other words, the range, you can talk about the range in a couple of ways. You could say the range is less than or equal to -3, right? Or if they use interval notation, you go from left to right, -infinity to -3. And it can be equal to -3, so I put a bracket around that. So this would be interval notation for the range. This would just be probably what your class uses. Y is less than or equal to -3 is the range. Okay. Graph 3 points. That's the last thing we need to do. Give me 3 values of x, and I'll figure out what y is.
You could do 0, 1, and 4.
Okay, good. 0. What's y when x is 0?
Be -3.
Well, that's going to be 1. 1 times -2, so we're going to have -2 minus 3 when x is 0. Not when that term is 0, but when x is 0, we actually have -5 as f of x, or y. Pick another value for x.
We could do 1.
Well, what's the problem with doing 1? I'm going to end up with the square root of 2, which I can't do anything with. If I want my y to be a whole number, then let's pick better values for x. What would be a better value than x equal 1?
2.
Then we're taking the square root of 3.
You could do 3.
Aha! Because then we're taking the square root of 4. We can do that. So when x is 3, what is f of x?
2.
Well, it's -2 times the square root of 4 minus 3. What does that equal to?
So that would be -5.
Well, it's -2 times 2, which is -4, minus 3, minus.
That would be -7.
That's okay. All right, what's another good value? We need one more point. What's a good number to try for x?
4.
Then we're taking the square root of 5. You got to find a value for x that the square root of x plus 1 is a whole number.
You could use 5.
No, that'd be the square root of 6. That's.
Then you could use 8.
There you go. Think of your perfect square number. Now 8 square root of 9 is 3, so we have -2 times the 3 minus 3. That's -6 minus 3, or -9. So when x is 8, y is -9. And you can see that that kind of matches the way that graph's going. As we go to the right on the x-axis, we get lower on the y-axis. And those 3 points are enough to graph that thing. But also, knowing the transformations were enough. All right. That's a lot for one session. When's your final?
It's out Thursday.
Thursday. Okay. David, it's completely up to you, but Patrick might be better served by having 2 one-hour sessions rather than a 2-hour session. But
you know, he recommended that, and I can see actually we've got some burnout factor basically on everybody. So, if that's okay, David, then what I will do is I'll go back on the...
If you want to pick, I can move it over right now. If you see something on my schedule, there's my schedule. You can pick one of these and move it to any other time before Thursday if you want.
Now, do you know, Patrick?
We should probably have one on Wednesday so I can like fresh my brain.
And now, what's your schedule on Wednesday? Is it a white day, silver day, a blue
It's a
day?
white day. It's a blue day, so I go in at 11:30.
All right, so you get out at 3. Would you like to do? Because that's I can't see what days. Is that Wednesday?
Yeah, I got almost nothing on Wednesday, so.
It's 5 o'clock.
How about Dave? What if we did a 5 o'clock on Wednesday?
Okay, which one do you want to take away from Monday? The 1 o'clock or the 2?
We'll take away the 1 o'clock and start at 2.
Yeah.
Yes, we'll take away, David, the 1 o'clock and start the one session at 2.
Okay.
And then on Wednesday,
At-
we'll do a 1 at 5, a 1 hour at 5.
Okay. Yeah, I think that makes more sense. Burnout really is a factor. You actually got a couple of factors going. You don't want to burn out. On the other hand, if you had a 2-hour test, you'd want to build your endurance up for it.
Right.
But how long are the tests?
They're about an hour and 40 minutes, a little less.
Okay, well, there's an argument to almost be made for a longer session, but I think the burnout factor is probably more important at this point. So,
Well, the other thing about this is he had other things today, and he's just at the process of putting his cheat sheet together.
Oh, yeah.
So, hopefully we'll streamline
yeah,
it and be
give
able
you a
to.
little extra time to figure out how to put it together. Yeah,
I just think that's a good idea because even if at 5, if we had a little bit run over, if no one else blocked in that time, I could go ahead and buy some more time if it was okay with
yeah,
you.
it's fine.
Yeah, so I think we'll keep it open, but I think that there's some benefit in that.
Yeah,
allowing him to
if we were preparing for ACTs or SATs, then I would suggest that as we get closer and closer, we do longer sessions just to build up his endurance. Same way that if you're going to run a marathon, you don't practice by running a mile.
Absolutely.
But if the tests are, reasonable lengths, then 1 hour sessions probably work better. I find just about everybody burns out in longer than 1 hour sessions, no matter who they are.
That's what Patrick said, and I said, no, they don't. He was
Your
right.
brain doesn't operate
So-
as efficiently in that second hour as it does in the first. So,
No, it's true, David. And the other thing about it is that obviously even going back over this material here, he may put in another session over an hour just going back over it. So, and the other thing is to access this recording. I want to make sure that we've got that because I know you changed that where they are.
yeah, let me show you.
Make sure I have it for
In
you.
fact, here, I can paste that link directly into, hold on a moment. Let's see, that's the link there. Click on that link in the window, the GoToMeeting window. Should open up another Explorer or whatever browser you're using. Click on that under the chat room in the GoToMeeting window. Do you see it?
Yeah, you get, well, we got the chat.
Okay, click on that.
There it is. Yeah,
I
yeah.
didn't have the chat drop down.
Well, we didn't have the chat drop down. It came up.
Okay, and now save that. That'll be the page where he'll be able to get his recording. It won't be till tomorrow morning, but in fact, if you saw that, you should see a bunch of sessions. Your session will have your initials on it, PD,
Okay.
okay? And
So tomorrow.
that's the way you do it.
Thanks a lot, David. Nice talking to you.
You're
David.
welcome. I'll talk to you Monday at 2.
Yeah, tomorrow.
Okay, yeah.
Got you Monday.
Bye-bye.